Welcome everyone to the monthly GameSalad meetup. I'm Alan Uthoff, lead developer at GameSalad and the organizer of the meetup. I've got a couple I got to hand over here to one of our employees, and Code Monkey on the forum is here with us, and Darian, and
Simulator guy.
So Richard is going to give a great talk about Hooke's Law and how to use springs in your game, which is going to be fantastic. I've peeked at some of his sample stuff. It's down there in the chat window. The link to his sample files are fantastic. You should check them out, and you can follow that way. You can follow along with him as he talks. So I'm going to go ahead and hand over to Richard, and let you guys learn about Hooke's Law.
Okay, great. I think I'm just going to talk for a second about Hooke a little bit. He was a contemporary of Newton, really a smart guy, but he wasn't a rich guy like all the rest of them. He had to actually work for a living, but the work he did was actually working over in England for the society for a bunch of those folks over there, all the lords and ladies who were gentlemen scientists kinds of things. But he was pretty much a working guy, but he was pretty smart. The problem was for him is that everybody kept taking his ideas because he was kind of like an employee. They would just kind of take his ideas and run with them and then present them, and then he was always, a lot of times he was in the unfortunate position of trying to defend work that he had previously done. A lot of that, hey, wait a minute, that's my kind of stuff. He even had run-ins with Isaac Newton along the same lines. In fact, their relationship deteriorated so badly that when Isaac Newton became the president of the Royal, Philosophical Society or whatever it was, and they moved their headquarters. Somehow they failed to take any of Hooke's pictures. They just kind of disappeared, and so we don't even have a picture of what he looks like. But he was pretty brilliant, and he came up with lots of different laws and principles and lots of different experiments. One of the things he worked on was better clocks and better watches. In fact, one of the things he did was created a spring, a leaf spring that were used in watches for a couple hundred years, really. And it wasn't until we started using the current technology instead of springs to using quartz technology and stuff instead of springs to work our timing devices. We've been using his invention all along. One of the things he came up with was called Hooke's Law. It was basically the idea that you could tell the force of a spring, its elasticity, and compute it out. It was similar, kind of like force is equal to, what is it, mass times acceleration or something like that, one of those kind of force laws like that. And he was able to show how to use these springs to get more accurate time. And I thought that it would be kind of interesting to see how his law, Hooke's Law, has remained in effect over the years. So without further ado, let's look at, I put out some examples, probably just kind of go through them a little bit, and that's probably the easiest thing to do. They're out there on the forum as well, underneath the meetup topic. So if anybody wants to go out and grab them, they can grab them from there. I think I'm just going to open up this first one here called Hooke Examples and kind of go through it. Okay. There we go. And I'll just open up the one scene it's got on it. I think I'll first talk about maybe the button here. Maybe I ought to just get rid of everything for right now. Just pull this down out of the way for right now. I think I'm just going to start with this button here and kind of talk about it for a little bit, and maybe that'll give us some ideas about how springiness works, I guess, and how the laws of elasticity work. So I'm just going to open up this button here. In fact, I'm wondering if I ought to just rebuild it as I'm doing this here. Yeah, I think I might. I'm going to get rid of, or at least minimize this rule and kind of rebuild it as we go along here. So this is just a regular button. It's got some button up and button down properties. Probably ought to run it. Turn this rule off. So it just turns off, turns on, that sort of thing. But what I want it to do is when I let up on it, I want it to spring, kind of like wobble back and forth a little bit. That's the general idea. So I'm going to skip this rule here and just recreate the whole thing and kind of talk about it as I go through it. So make a rule, put it up at the top, and basically I'm just going to say when, let me see here, when touch is, up here is when touch is pressed, right up here, and that's how it's toggling on and off, but I'll put down here when touch is released. Okay. And the first thing I want to do is change the size of the button, kind of make it, enlarge it, so it springs outward. So I'll just do that really quick with a couple change attributes, both for width and height here. So change attribute, button size width, and button size height to, well, let's say 150. Just make them really jump. Something like that. So when we release it, they just get bigger by 50 pixels wide and 50 pixels high, something like that. And then I want to actually create an attribute called force, and this is what he would have come up with. Hooke came up with the idea that you could figure out the force which spring or an elastic body would spring back or forward, that sort of thing. And we'll see if we can make kind of like a little watch spring or something like that. So I need to make a, well, I probably already got it. Yep, I've already got it here. An attribute, we'll just name it force, and we'll go ahead and start constraining that attribute. Constrain behavior. There we are. And I'm going to constrain that to attribute called force. So button force, and I'm going to constrain it to itself. Okay, so button force plus, we'll do it this way, plus parenthesis 0.2 times parenthesis 100 minus self-size width. Once I get it built, then I'll talk about it. Right here. Size width. A few parentheses. Let me see here. Times 0.9. Okay, this will help. And I'm missing a left parenthesis. Something like that. Okay, so I'm going to talk about this for just a second here. So force, this is the force that I want this button to spring back to its normal resting state, which ought to be about 100 pixels. That's this number right here. So we are adding its current, this stuff to its current force. Okay, and this stuff is basically Hooke's Law. I'd like to talk about it just for a second here. Hooke's Law says that an elastic body will contract or expand given its the difference between its resting state and its current state times a constant. In fact, I'm going to take off this number here. Okay, we'll see what that does for us. Okay, so this is basically Hooke's Law, this part right here. This is saying that an elastic body will rebound based upon the difference between its current value and its goal value, its target, its resting state, however you want to say it, times a constant. And in this case, I just took out of the air 0.2 as a constant. If you think about it, that makes a whole lot of sense. In fact, it's amazing that this law wasn't common knowledge, right? Something is going to spring back at a, it's going to spring back to its resting state. So you got to tell the difference between where it's at now and where it wants to be, its resting state. And then obviously there are some properties of any elastic body that's pretty constant. So a spring is going to have so much tension to it, something like that. A rubber band will have so much tension. So this basically, this point 2 here is the property of the actual object, some constant value that it has, like tension or just elasticity or anything like that. Well, let's give that a try and see what we've got here. So I'll hit the check here, and let me see, did I turn off the other rule? Yeah, okay. So let's just give that a try and see what we get. It went big, but it didn't go small. Okay, so we're getting there. Let me see what else we need to do here. Probably do need to put in that 0.9 there. So the next thing I'm going to do is add to it, just like this number here, this 0.2 is a constant that represents the properties of the spring itself, but we've also got some other stuff going on. We need to figure out the property of the environment that it's in as well, like friction or something like that. So I'm just going to multiply by multiply by 0.9, and so we're just going to say that this whole thing just gets a little bit less force each time. This basically is like friction. It's just going to be a part of itself coming back. So this number here represents the difference between its resting state and its current state. This number here represents the constant, or the properties that are inherent in the object itself. And this number here represents outside environmental factors like friction and stuff like that. That's basically the idea. Okay. Now we need to see if we can get it to move back just a little bit. Let's see what we got here. Okay. It's getting closer, I guess. So what we need to do now is we're going to add, once we got the force going, we're going to add the force back into its width. So it will look something like this. This is kind of like an interpolation, really. We'll use another constrain, and we're going to constrain its width to its current width plus some force. Okay, so button width, size width, to its current width, size width, plus that force we just computed up here. So button force. Okay, let's see what we get there. So it's adding the force into its width every time as well. But notice that it's because we got that little friction, that 0.9, it's actually making it smaller every time. So that's basically the idea. Now that looks kind of weird, so I'm just going to go ahead and also constrain the height to the width so that it looks square again, something like that. So constrain button. Your size height to its current width as well. So we'll just square it up. Okay. And we'll give that a try. Okay, so all of that gives it some springiness. That's Hooke's law. So we could, if we wanted to, give it different properties for height and width. But for what we're doing, since the button's supposed to be square, we could just do it that way. But you do get, if you do use height separately, create its own springiness, you get kind of that wibbly, wobbly kind of effect that can be kind of useful as well. But that's basically the idea. So once again, this is all Hooke's law says is find out the difference between its resting state or its target state or whatever you want to call it, its reference, and its current state. Multiply that by the constant that's inherent in the property of the object itself. And then multiply all of that, and then add it to force, its current state, and then multiply all of that by some environmental factor, like friction or something like that. And that's basically Hooke's law. So given all that, we get this. Or if we want, we can also look at the urchin there. Bring that up. I won't go through as much of it this time, but I guess I will open it up. Well, we might as well just play it. So the idea here is that you can do the same thing, but instead of width and height, you can just do its x and y location. So it's like on a rubber band. It's always going to be trying to follow where the mouse is. I'm just clicking on it and dragging. And so it's got a little bit of elasticity to it as it goes back and forth. And you know, you can work that up and down a little bit. So I'll just kind of go in and talk about that really quickly here. So urchin, open that up. It's just got some animation on it, but basically it's the same kind of thing. Here I've made a variable called x reference, right? Self x reference. That's basically going to be the standing point, the target that it's supposed to be looking at, its reference target. And all that is the mouse position. Okay, so when the mouse, when it's touched, when the mouse is down, it's just going to look at the mouse position and put it into that x reference. Okay, so if I open this up, okay, so we're still using the attribute called force once again. So if we look at this one, it looks like this. Once again, we've got force times 0.2, that's the constant, times the difference between its current position and x reference, which is the mouse's position, times 0.9 again. And that's all it is. And then we're taking that position, then we're taking that force, and instead of adding it to its width, we're now adding it to its current position. So force plus position. And that's how we get that kind of rubber band kind of effect. Now, you can mess with those parameters, or those the constant, and you know, it's constant, and its friction or its environmental effects, if you want to, and you get different feel for things if you increase them or decrease them. So it's largely a matter of using the formula as it's shown here, but then using different numbers. 0.9. If you don't want it to, if you want it to be really slidey, you know, you can make it 0.999, and that'll make it even more slick. I don't know if you can, yeah. And it'll oscillate a whole lot more. Finally slows down because it's basically you know, almost 1, and it's you know, if you put it down like to 0.8, that would be even more friction. It's slowing it down by, you know, 0.8, and you notice that it's a lot slower now. Perhaps the constant here, maybe it's really springy. So instead of 0.2, we'll make it like 0.5. This is probably going to go off the charts. Oh, that helped it actually quite a bit. I like that better, actually. Yeah, so anyway, the formula works. You just have to kind of mess with the numbers there, and then get it to where you want it to work.
Hey, Richard, we have a question real quick.
Sure.
Would you build the same code to add the y to it also?
Yes, exactly the same. It's just you'd want probably a different force. Well, it depends on how you want to set it up. You could use force for both of them, but you could have x force and y force, just like you could have x velocity and y velocity. Let me see. So this was kind of this was just showing how to constrain x and y positions and that sort of thing. But you don't have to use constraints. You can use any of GameSalad's other properties to or behaviors to do things as well. So I'm going to open up this one, this bowl boy here, And here we're just using a move behavior instead. So I'll play it. Move this up a little bit where we can see it. And it's kind of like the urchin, but it's not using any constraints. It's not constrained it. Instead, oops, there we go. There we go. I'm slowing down on me. Instead, we're just using a move behavior instead. But if you look inside the speed, it's basically the same thing. I've moved things around a little bit, but it's still the difference between where it wants to be in the mouse position and where it currently is, times the constant, and then times environmental factors, and then I just had to slow it down with another 0.9. In fact, I could probably just change that to, say, 50 times 0.9. Mathematically, it'd be the same. But that's basically the same Hooke's law, just some different numbers thrown in. So yeah, and just using a move behavior instead of constrain. The reason I can do it this way, instead of having to constrain a force like I did before, is because the move behavior is additive or stacked as well. And so it's kind of adding that stuff in already. It's saving a step. It's saving a constraint. Just because it's additive already. So we don't have to add force to X position. Okay, so yeah, we can get stuff to move as if it were, you know, on a rubber band, a very tight rubber band in this case, but that's kind of the idea. You can have things spring back and forth, go all over the place, and because you can use a move behavior, you can set it up so that it will respond to other objects and obstacles, you know, so it'll bounce around and that sort of thing as well, which is kind of the nice part about being able to use a move. Why I wanted to show it, rather than just using, you know, constraining X and Y and that sort of thing. So that's kind of that idea. So once we got this bowl boy kind of moving like this, why not see if we can put him on a stick and make a bobblehead kind of a thing? So that brings up the next one here, and this is the bobble bowl boy. So if we open up this one, it's basically going to have the same thing in it, but in here it's going to be following the stick along. In fact, we'll just play it.
I got one more question for you, Richard.
Yeah.
Dave asked, so in the constraint, could we use the mouse X velocity?
Yes, you can use any attribute that you want to have it go back to for the reference. Yeah, you can do all of that. Yeah, and this might show an example of how to do that here. It might be answering the question, so let's give this a try. So basically, we've got this, I'm dragging around this purple body and trying to then have the head follow it and then getting it to bounce around a little bit as well. So I'm going to open up the bobblehead here. Oh no, I think I opened it up this way. Yeah. So I'm not sure why I needed to do this, but I unlocked the actor. So it's an instance on the scene. Oh, I know how I did that. Because I was going to, I used the purple actor's position. That's what's going on. Okay, so when touch is pressed, change its rotation to rotation plus 20. That was just to, in case I didn't want to move it around, I could just make it jiggle like that. That's all that is. Just so it kind of flip and then kind of go back to its, spring back to its reference state. Okay? And then I constrained the bobblehead to its angular velocity. Actually, no, I think I'm going to do it the other way. I'm going to talk about this one down here, this move, because the move here is more like what we were just doing. So that's probably the easiest thing to do. In fact, it's a lot like what we were just doing, except here, instead of using the mouse, I'm using that the body, the purple body position instead. So it's instead of the mouse, we've got this, but it's the same kind of thing. Times or minus its current position times the constant, and then all of that times the environment, the friction in this case. And that is kind of how it's keeping track of and moving with the head's moving with the purple body. So not looking at the rotation yet, just having it track, trying to keep on top of the body. And you can make that harder or softer, tracking just by changing those numbers a little bit. So that's kind of the idea. You notice that I had to change that number before I used 0.2. Now it's all the way up to 20 instead. So I'm really multiplying it quite a bit in order for it to track correctly using the move behavior. Okay, now I'll talk about this constraint here. So this is the bobblehead part. And I'm going to be constraining its angular velocity, to getting it rotating around. And it might look a little convoluted, but here is Hooke's law right here, right? This part. So I'm trying to get it to rotate back to 0. That's its reference spot. So the difference between 0 and its current times 0.5, that's the constant, times 0.95 is the environment. So that's that part of Hooke's law. And that's making it just kind of settle back down to 0. This part here is its current angular velocity that we're adding it to. So whatever it's currently rotating at or how fast it's rotating, we're going to add that to this part of Hooke's law, right? So that should look okay. But here was the fun part. I'm adding here the since we're already tracking it here with this move here, I'm adding the velocity that it's gotten from trying to track that purple body. I'm using that as part of the rotation as well. So I'm however fast it's moving across in the x direction, however fast it's moving across the scene, just taking that down a little bit to times 0.5 plus all this other Hooke's law portion. So that gives it that kind of weird kind of, oh, I got to catch up with the body, and the head kind of tilts just a little bit. So if you watch this here, the head tilts, that's the movement, right? And then when it comes to rest, then it's no longer got any of that x velocity, it's no longer moving, so then you can just get the true part of the rotational velocity. Hooke's law acting like a spring there.
Bobblehead.
Okay. So that's our bobblehead, and you can mess with that and increase or decrease its wobbliness and all of that. Okay, and then finally, Hooke was really into earthquakes. He was a geologist and stuff as well, so I thought I'd throw in here making a little springy camera control that would simulate an earthquake or something like that. So I'll go ahead and open that up. And so here are some of the assets, the croutons that you guys have supplied for us. Thank you very much. And the idea here is, if we just play it, the idea here is that when you click on the mouse, you can just make it spring back and forth and rotation and that sort of thing. And so to do this, you need to have a camera control actor that's actually on the scene. And so where is mine? Let me see here. I'll just go to layers, background. There it is, camera control. Oh, there it is right there. Okay. And so here I'm starting out looking at, first of all, trying to get target width and target height and target rotation. So this is just the scene's resting state. The things, this would be where we wanted to get it back to. So I just recorded those off of its current width, height, and rotation. And then the rule here is whenever the mouse is down for 2 seconds, let's start jiggling the width, let's start jiggling the height, and let's start jiggling the rotation. So we've seen how to do width and height. well, I guess we've seen how to do the rotation as well. It's going to be pretty much the same kind of thing. So we're starting out with changing its width to its current width plus 20. Then changing speed to, and really this is kind of the force. Speed, force, same kind of thing. I was using force before, used speed here as an attribute. But if I open this up, it's going to be the same kind of thing. I created some more attributes over here. K is the constant. That's the tension or whatever, the spring. Dampening, that's the 0.9. That's the environmental factors. So it's the same kind of thing again. It's just using some attributes. So there's Hooke's law. So it's looking at width plus the difference between where it wants to be and where it is, times that constant, times friction or dampening. So it's just the same formula over and over and over again, just slightly different values. Same thing for, so that's width. Same thing for height. Exactly the same things. But to get the cool effect, I guess, is to actually get the whole camera to rotate as well. So same thing, camera rotation. And here we're using rotation speed, but it's the same functions. And then we're just constraining its rotation to whatever that rotation speed is. And really, I shouldn't have named that rotation speed. It really is rotation force. I should have been better about that. But that's basically the same idea. This is not a speed calculation. This is really a force calculation. And then from that, we can get kind of a fun little camera shake. And I think that's it.
Thank you so much, Richard. Anybody, any questions?
It's just surprisingly direct, like
What?
it was surprisingly like direct. I got it really well. No, it's awesome.
Yeah, that's a great presentation. I have a question about trig functions.
Uh-oh.
I know I'm using, I'm trying to create characters to have life and motion, and one of the ways I do it is just to use a simple trig function to get an enemy to wave back and forth. But this looks like a whole nother way to get oscillation and natural movement, so I really like this. It's almost simpler than the trig I'm doing.
Yeah, you could achieve the same things. This is more like a simulation rather than an animation, if that makes any sense.
Yes.
This is how you would simulate those elastic movements rather than animating them. You can also use trig to simulate them as well. And to be honest with you, there's a whole bunch going on behind the scenes that's already built into the move behavior. You know, and so that you don't have to do a lot of the trig. But oftentimes if you calculate everything out, you're going to find that you're doing the same thing mathematically. It's just another way of doing it, really.
So it mathematically simulates oscillation. How does it do that? Does it overshoot its target?
Exactly. That's exactly what it's doing.
Okay.
So yeah, if I go back here to the camera control, where is that? There it is. So basically, like with this rotation here, it's over-rotating because we're adding so much, we're multiplying here by just enough to get it to over-rotate. And so then it's got to bring itself back. And in fact, this is what Hooke's law really works well for. Is you can get oscillations going that are quite predictable. It'll just oscillate forever, just like a timepiece. That's kind of where it all came from, trying to get a spring and a leaf spring to oscillate, and that's how they made watches. So I'm thinking here, I probably should have done one where we just tried to make something move back and forth. You might, let me see, can I just grab, let me see, has this urchin got anything on it? Actually, we could probably just do it from here. So if we did the same kind of thing, see if I can rough one out here real quick for you. So I'll go ahead and use force again or something like that. I don't know, is it worth trying to make an something oscillate, or is that, you guys have to tell me, is this interesting to you or not?
I think we have plenty of time. I think we gotta go for it. Yeah.
Okay.
You got plenty of time.
Okay, so let me see, can I, yeah, we'll try it this way. So if we do that, we want to go force, right? So we're going to constrain the force to, let me see, we'll just say, we'll try to put it sort of close to the middle. 300 minus its current position, position x. So, yeah, we'll put this in parentheses here. So the idea here is that this is the difference. We're going to multiply that by, well, we'll just use the same formula, 0.2, something like that. Okay. Put all that in parentheses. And we'll leave off the friction. And let me see, we might as well add in force here again. There it is. So force plus the difference, that should do it. Okay, and then we'll use another constraint, and we'll put its position, x position, to urchin, and we'll do force first. Force plus position. Let me see if I've got that. Yeah, okay. So without friction, it just oscillates. And that's what he invented. That's the spring that's inside every old-fashioned watch. Just something that will oscillate back and forth. And it'll oscillate forever until you add some friction to it, right? Times 0.9. And now it'll just, whoops, did I do something wrong? Well, okay, what did I do? I need another set of parentheses. This whole thing, friction is for the whole thing. There we go. 1, 2, 3, 1, 2, 3. Yeah. So without friction, it just overshoots constantly and will never come to rest. So yeah, that was probably a very long and convoluted answer. The answer is yes, it overshoots.
Thank you.
So Dave has another question for you, Richard. So what gives? So what this gives is organic friction where trig won't?
Use trig functions as well to get friction. I just stuck it in there so it'd be nice and easy. 0.9, makes a lot of sense.
Yeah, it'll give you a more, I think the idea is it gives a more organic oscillation where the trig, unless you're building in some more complex trig, will just be more a regular thing. This will take into account more things like friction and other.
So if you plotted out the we're doing it in X here, I guess. If you plotted out its position, you would see that it's a rhythmic movement, and you could use trig then to create this create that same slope for the movement. You'll say waveform. So trig is a way of describing the waveform. This is a way of actually simulating the properties of an object. Trig allows you to animate the positions, but this allows you to simulate the properties of the object. Does that make sense?
Yes.
So one of the problems I see all the time is when we're using those trig functions to get something to oscillate back and forth, we're using time, self-time, or something like that. But that's an animation. It's moving things the hard way. It's not necessarily simulating the properties of the object, of the actor.
So we have another question for you, Richard. Peter asks, how could you implement this with collisions?
Oh, yeah. So one of the ways, one of the things I was trying to show is that you don't have to constrain the position. You can just use a move behavior or any other behavior that allows the the collision detection and physics to continue to operate. So like the bobblehead, it's using a move behavior. In fact, let's see if we can just do that. If I close this, we'll go back to that bobblehead. And we should be able just to create an actor and have it collide with, right? So physics, we need to give it some really heavy density or whatever. What does density go up to, by the way? What do those numbers mean?
I have to go look them up. They're from Box 2D. They're usually in some correlation to pixels is usually what you do. But yeah, if you search like Box 2D density, you probably get the range. It's been a while since I've looked them up, so I can't pull them off the top of my head.
Okay, well that's good to know. That helps.
Look this up on Box 2D.
There we go. Movable. So I've turned off movable on this particular actor, and I've give it pretty big density. So now I can go into, let's see, I think I did it in here, didn't I? So now I can go into here and give it a collision, right? Collide with actor of type actor 1. I didn't give it a name. And if I've done it right, it should collide with it now. That wasn't pretty. It's because I'm only controlling the X, not the Y. But it'll collide with it, right?
I got another question for you, Richard, whenever you're ready.
Yeah.
Okay, it's kind of a long one here. Brent asked, would this be applicable to a UI list view refresh? For example, Twitter has pull down to refresh feature where it's elasticity when you pull down and springs back when you let go, but there's no jiggle. It's more controlled.
I think you could probably use this. I think I put out in the forums a kind of a UI picker control. No, actually, it was more like just having the text run up and down. That is, I guess, maybe a derivative of this. I hadn't thought about it this way. What I put out in the forums was a way to do that with it's checking for its topmost position and won't go beyond that, and it's checking for its bottommost position and won't go beyond that. It's using the same kind of springiness, so it'll kind of spring back. But you might want to, they might want to go out and check the forums and see if and see one of those out there that I've put out there.
Any other questions, or any more questions?
Have you tried stringing a bunch of things together with have them move, basically set up a series of strings, sort of like things connected by rubber band?
Oh yeah. So this is a partial equation to a joint. You could create cloth. You can create rubber bands all hooked together. You can do all sorts of things. And yes, I've done those in many different ways. Created chains and strings and stuff like that. Basically, to do it right, you have to have them reference each other. It has to, if you're going to have stuff strung together, they need to go toward, actor 1 needs to move toward actor 2, and actor 2 needs to move toward actor 1. It's kind of a mutual referencing. But yeah, you certainly can do it. It's because Box 2D isn't, because it's already kind of, loopy, it's kind of loose itself. You may not, it kind of vibrates and gets a little, there are little oscillations and stuff like that. But generally, if once you learn how to tweak the numbers, you can get something that's usable in terms of making a chain or a string or cloth or those sort of things. Of course, you're going to run out of, you only get so many constraints before it starts slowing things down. But yeah, it's theoretically, yeah, you can do it.
I was hoping I could see if I could find you a range of those on Box 2D, but unfortunately, there's not a very quick here's the min-max. They're very
Yeah, well, that's helpful to know. I didn't know that they came from Box 2D, so I can go out and look that up.
Yeah, basically we feed those right into Box 2D and let Box 2D simulate physics. Theoretically, I don't know what Box 2D. I have to look up what it. I think Box 2D takes a maximum float. Yeah, I'm pretty sure Box 2D takes a maximum float. But theoretically, you could throw in whatever the max float is, and if the range works, it probably will work. But I don't know if internally Box 2D has some range calculations to not make things go crazy.
Right, I didn't know if it went from 1 to 100 or 1 to 1,000 made sense or that sort of thing.
Yeah, I don't know. Like I said, unfortunately, they don't have a very good manual on ranges. They do have a manual, though. You can look up the Box 2D manual, and they'll go through all the stuff, like what this piece means and what that piece means. And
yeah, now that I know that, yeah, I'll be looking that up to see what they are, those ranges are.
So I think the only thing you may find different is we renamed restitution to bounciness, because most people don't know what restitution means.
Right. Yeah, I thought that was a pretty good thing to do, actually.
There's any other questions here? Any other questions for Richard on springs and Hooke's Law and Hooke? All right. Well, thank you so much, Richard. Fantastic.
You're welcome.
We'll probably come after you for possibly the GameSalad Learn channel if you're interested in that. We can put this meetup up on there.
Sure. Yeah.
I guess we might have questions in general for GameSalad, because I know a lot of people come on here looking for GameSalad questions as well. So, if anybody have questions about GameSalad or have questions for us, or any other general chats we want to talk about? Oh, the classic tvOS. I'm assuming, Jesse, you're talking about Apple tvOS or the Apple TV? Yep, okay. So yeah, so first of all, we couldn't get our hands on Apple TV dev kit. So we don't even have one in the office. So right now we're still doing the investigation part. There's actually a couple pieces that make it difficult. So right now we're just still investigating. We right now have no plans to support it, especially during launch. We're just going to investigate and find feasibility for right now. Plus, like I said, since I don't actually have one, a little hard to actually figure out how hard it is to develop for. I have read the SDK, but that SDK and actual device are two different things entirely. So yeah, so right now we're not supporting it. Peter asked, I don't know, Peter, you're asking this to everyone else? If so, I can unmute you. Marketing ideas that have worked for you. I guess in general for marketing games, Or have you had any success?
Places where people play games and have them play it. And I don't know, I've noticed now it's weird. I go places and people around are like, "Oh, so you're making that game?" When I say when I say the name of my game, Pocket Smash, which is really weird for me because I don't expect anybody to know what I'm working on. And doing something that looks like a bunch of people are having fun, that like it draws its own natural interest. Because I'm focusing on on-device multiplayer. Anytime I actually show my game to somebody in a crowd, like people will just come by because they're just not accustomed to seeing two people on the same device. They're like, "Oh, what's happening here?" And so they come check it out. But yeah, actually getting out there and getting your game in people's hands is the biggest fun now.
Yeah. Ted asked about El Capitan support. I've been actually working for the last 2 weeks on El Capitan support. I think we have a stable build. Hopefully tomorrow. Guys. A build for El Capitan. And then hopefully next week or the week after, we'll get the release out for us compiling against the iOS 9 SDK. Had some issues with that, but we'll push out the El Capitan update for Mac creators hopefully tomorrow or Monday. Sorry, I'm going through these. Got a lot of questions here. Hold on. Okay, Dave asked, and maybe Richard, you could help us a little bit too. What does stacked and additive do in the behaviors like move to? Or maybe I can get. You want to answer that, Jonathan? No, you don't. Versus what's additive versus stacked?
All right. So additive means if you have multiple behaviors using that same. I don't need the camera. No. So if you have multiple behaviors that the same behavior, say like move, their total velocity or speed or whatever, they get all added together and then they all work at the same time. Stacked means the last one that gets activated overrides everything else.
Okay. If I have, I'll come back. I'm still going through them. Scott asked about roadmap and for turnkey networking support without having to set our own server. We have a few technical hurdles to reach before we can offer Place together as a service. And I don't have a roadmap. I've been asking for CodeWizard. CodeWizard doesn't have a roadmap. I don't have anything for you. You'll have to pester CodeWizard on the forums. Right now, we're just fixing bugs, stabilizing the tool, and making it a better product. That's kind of our current working roadmap. And anything that falls into those kind of categories is kind of what gets worked on. Once we come into more stable and a better release, we can start talking about what features should go next. But unfortunately, things are fluxed too much to really give you a solid, here's the next feature, because our next feature is fix those bugs, make things stable. I think you got your, okay, John's asked about engine improvements. We'll get to them as we go. We're focusing on stability right now. So as we can find things, we have found some things we need to improve in the engine, and I'm not sure what we're going to start next, but we're going to make the engine perform better in part of our passes to make things more stable and useful. Yeah, actually, that's Jonathan on here, not Jonathan in the room, asked about image handling, decreasing load times. We're looking into decreasing load times to see what's going on. So many questions. All right. Hopefully, like I said, we're looking at stuff. Again, we don't have a roadmap working on. We're just trying to make the product better and making it more stable. Again, Jonathan, maybe you can help me with this one too. When resetting a scene, is there a quick way to reset values from a table as well?
Not really, unless you have like an actor that is, if you have an actor that's in the scene, if you restart the scene, that actor in the scene will start kicking off stuff. And then you can, if that actor has all the behaviors that say change table values, or if you have like a base, if you have a default table, they can just copy that over to the new table that will just overwrite the old table.
Yeah, I was thinking copy table maybe, and then.
Copy table?
Yeah, that's
how you do it. Then you just make you make a table that for the original value.
Yeah, but that will wipe the whole table to the default settings. If you only want to change a couple things or a bunch of things, but not everything, then you have to go hack and slash to small parts of it.
Yeah. And then you can also have, if you want all your actors to reset based on value, have the individual actors read from the table once it's been updated. And right, reload table would be nice. He's asking for a reload table value. Oh, we have a feature request. We can put it as a feature request. Yeah, we're also going to do some passes on table optimization. I just don't know when yet. It's part of our stability. We all know, internal all devs know that the tables library and tables stuff needs some optimization love. So it's something we're going to look at. I just don't have an order of when we're doing it. Any other questions, or do you want to do some sort of survey, Pam?
No, I didn't have any set up.
Oh, yeah, right there.
Thank you. Let's see here.
Ted asked about custom fonts. Not quite there yet. We're still dealing with some more technical hurdles. Again, another thing we all know about, we got to get custom fonts done. But there's a few stability and performance things that need to happen first before we can tackle that. And I guess too, if you guys have feedback for us too, what kind of things do you want to see at these meetups? What kind of topics do you want to talk about? Usually it's me kind of pounding the pavement, trying to get people to present awesome things. We have a couple people in the forums who are really good about responding to that. In a pinch, Tan and I will do presentations, but I'm open to all kinds of different things. If there's certain topics people would love to hear about, we can find somebody to come in and talk about that, or one of us can, if we have that knowledge, we can talk about it. So if you got, put any other questions, put in things you guys might want us to talk about or have in our meetup. I'm definitely looking for somebody for November. That's the next month. November's meetup. So if you have a topic you'd like to talk on or suggest a topic we should talk about, please let me know. We're going to put in the questions here. So one thing I want to speak about earlier, someone was talking about the place together. There is still an alley build you can use, and I think GameSalad Guru posted about how to use that. So if you really, really want to play place together, you can go grab the old nightly build and play with it. But at some point, when we get some more technical hurdles solved, we'll get that out to you guys.
Wow, no one's on nightly anymore.
Yeah.
I guess we're improving things.
Yes.
Surprised there's not more bold versions. I'm just like, that's where I've gotten to. I'm just like, don't upgrade unless you have to. If you have to, then upgrade, but otherwise, stay right where you are.
I can understand that. Yeah, we actually try really hard to not break things, so that you ideally can upgrade without. Yeah, we try to be very forward, so we're backwards, so you can move up the product, and if we break something, we migrate your project up to the appropriate change. So say, for example, we removed, at one point we were going to remove percentage, so we would just migrate everybody up to use a new mod function. We did that. There was a couple other things, like restitution, for example. We moved everyone over to bounciness. You didn't have to go change your thing to say, if you referenced restitution in your expression, we just changed that for you to bounciness, because we knew that's what needs to happen.
Yeah.
And so you don't have to go do that. So we would try to make it so when you upgrade, we don't break projects. Did you take down the nightly builds off the website, or they're still?
I know the release candidates are still there. I'm not sure about them now.
Okay, well, the nightlies are up there. If you can just message me if you really want to play Place Together, we'll give you a nightly build you can play with Place Together.
We don't give them an account.
Oh yeah, we get you an account set up too. So we're still dealing with some technical hurdles. There are some things that are kind of
nightlies, that's why.
Yeah, okay, so yeah, if you want to play with it, let me know. We'll get you a nightly build so you can play with it if you want to play Place Together. But things are very much in flux and still in development, so just FYI, it's very much a beta thing. Once we get it squared away, then we can send it out to you guys in the stable. For if you want to build or if you want to play this place together, message me on the forums, and I will get you set up with something to play the place together.
Oh, hey, we got some people who can show off stuff next time.
Woohoo! So if you want to show off your awesome topic, which I'd love you guys to do, message me on the forums, and I'll get you set up. Just send me, all I need is the name of your presentation, short description of what your presentation is. Oh, games seems fantastic. We can do games too. Same thing. Just send me the name of your game, description of your game, and we'll just get a list going. And
hey, if anyone wants to show off a game now, let us know. We can give you we can let you take control for a bit and show it off.
Oh, I'm sorry because I don't have the camera. Do I have the camera? Oh, can't see the camera. I'm sorry. I said me and the camera's not on. Sorry. This is Alan, the lead developer. I'm Blackcloak GS on the forums. Message Blackcloak GS on the forums, and I'll get you set up to play together. Oh, here we go. Here's the game. All right. Let me see how best to do this. Make me a presenter, Tan. Or unless he wants to be a presenter. Okay, let's do it this way. Jonathan, not Jonathan on the call. Jonathan, this is French call. Yeah. Do you want us to show do you want to be a presenter and to show it on your screen, or do you want us to show it here?
All right. You are now a presenter. If you don't want to, just let us know.
He doesn't want to be a presenter. All right. I'll pay post it here. Make me a presenter. Give me a second. Hopefully I can play your game right here. You may have to give me directions how to play this, Jonathan. One second, I'll show you. Typing some things here. One second, I'll show off the game. Did you make it so we can talk, or?
Does you want to make it?
I don't know, I guess we can show it off here once again.
The audio's connected.
Okay, so apparently this game, let's see, where's my screen? Hold on a second.
Also, you know you can share a particular window, so you don't have to share.
Oh, how do you do that?
The drop down in the show.
There is no drop down in the show. I just have a big button. Is it up here on the,
Oh, yeah. So, go to screen sharing. Oh. And click on that. Now you can pick which window you can share, so you don't have to share your full. So play catch.
There we go. Ah, all right, there we go. And then, so redirect, and once you get the pull down. Okay, so here's Jonathan's game. Like that, so all right.
Oh, this game. So you're going to need to use A and L keys.
A and L keys? Yeah. All right, Jonathan, so I'm going to play this. I have no clue how to play this. Okay, how do I A and L? Oh. Oh, I'm not good at this game. Oh, I see. Oh, I see. Yeah. You. Oh. Oh.
Yeah, we just saw this earlier today on Hunger Games. Now.
Want to answer questions if I'm playing this game? I'm not good at this game. How do you unmove his hands? Go the other way.
You can't.
Just kind of like try to. Yeah, not good at this game. Fun little game though. Oh, we're gonna do that. Okay. Yeah.
Closer is the D.
Oh, there you go.
Oh, yeah.
Hey, all right. Oh, I think it was. Probably doing better now. All right, there we go. That's pretty cool. All right. All right. Questions here? All right.
So the results from before. So it looks like how to make their people's games better and how to sell their games. We may need to find someone to help us with marketing stuff. Anyone who's an expert on game marketing, then you know. All right, question. Our last arcades and saw games. There's a bank. Ted Castle's offering to do a quick.
Yeah, I'm talking to you right now.
Build it out.
We also do a bunch of little small talks too. If everybody has a lot of things.
So for everyone in the poll, none means it's supposed to be non. Sorry, mistype. There is no option for not using it, so just don't.
Okay. Scott P says to copy a row from one table to another, I grab the row and iterate through every column in a loop, writing the values to the destination table column by column. That is the best way to move a row. Or is that the best way to move a row?
Yeah. I can't think of a better way.
Yeah, I can't think of a much better way either. I guess, yeah.
But you have to assume that all the columns are exactly, is it within a table?
Copy a row from one table to another.
So
Well, you have to make sure like both tables have the exact same data types for each column.
Do we do any autocasting for that? Like if you're an integer, it just turns into an integer string?
Not in, I can't remember, I have to go look at it again. I can't remember which move things over.
Just do one. Like you can do change table body over row columns.
It's either Jonathan Francois
Jonathan.
or you. Okay.
All right.
I think that brings us to our final two questions.
Let me see if I can.
Oh, really? No one thinks they can do better? That was an awesome presentation, but really, yeah. It's a challenge. Wow, that was great.
Well, I mean, he did kind of like take a scientist, you know. Like,
yeah, that's true.
Obviously, that was pretty impressive. I thought. Like, I actually looked up the formula, and I'm like, oh yeah, there you go. I'm like, that's pretty spot on. Like, I was intimidated.
Always the classic when we end with. It's like our classic forum or message.
All right. Obviously, people think we're not done yet. So, do we have any other questions that they missed?
Yeah, anything more I can answer. Always happy to do stuff. Lots of people happy with the presentation. Thank you again, Richard. It was a fantastic presentation.
Yes.
Okay, who are the smart asses who said no?
Maybe they never went in. Maybe it's like the never ending story. All right, I'll give you like 1 more minute. There's no more questions. Yes or no, so you can go home. Nobody's answered the table yet. All right. I think on that note, I think we'll wrap up the meetup. Again, thank you, Richard, for your presentation. Next month, we don't have a talk yet, but I'm talking with some people already to try to get a presentation going. So if you have an idea or topic, again, I also need one for December and November. So if you guys have a great topic you want to talk about, or if you want to drop a game or a cool feature you did in your game that you think a lot of people will be happy with, message me on the forums. I'm BlackCloakGS. And see you guys next month.
Thank you.
Let's see, next